Hi, my name is Jared Lopez from UPRM, and this is my entry for the GMiS Research Poster competition, and it is called Third-Party JavaScript Implementation and Security on the Internet. Let's get started. For the last couple of years, there are more websites that are using third-party JavaScript libraries, and even though most of these libraries contain useful tools for developers, there are some libraries that contain vulnerabilities for their users. These vulnerabilities may cause the user to experience web attacks, one of the most common of which being cross-site scripting, and we need to avoid that. So the main goal of this research project is to find how many files from the third-party JavaScript libraries contain vulnerabilities, and how many contain the best protections available, and it was done with the development of a web crawler. The web crawler was developed using Python, and it will accept text files that were given by the user. And for this research project, the web crawler gathered the data of the Alexa top 500 US sites. The web crawler will then generate a .csv file containing all of the data, and it will have the websites crawled by the program, the amount of JavaScript files per website, the JavaScript files of the websites, the full headers of each JavaScript file, and the CAHSI control that's modified and expires of each file header. After the data was extracted, was analyzed and find how many JavaScript files set the recommended security headers. And here's an example of the web crawler in action. On the left is the terminal with the web crawler, and it will contain all of the websites that the crawler has implemented so far, with how many files the crawler extracted and the amount of time it took for it to extract the JavaScript files. And on the right, it's going to be the website that the web crawler is currently extracting the data. And on our next slide, we will find the first figure. For the Alexa top 500 US sites, we found a total of 12,508 files. And this figure will have the recommended security headers, except for two cases. The first one being the cross-site scripting protection 0, which it will actually disable cross-site scripting protection. And the second exception being the extreme options allow all, which is the default value of extreme options. But if you keep it in allow all, the site may be susceptible to clickjacking attacks. And as you can see, the overall usage of security headers on our JavaScript files found was low, with the highest being strict transport security at 22.07%. And in our next figure is the CAHSI control metrics. We found a total of 10,149 files that set a CAHSI control, and the highest one being the public header that was found with 38% usage. And even though it is okay to use the public, but if you're going to use sensitive information like banking information and social security numbers, it is best to use the private metric. And in our next figure, it's going to be the average max age, reflecting per 100 websites on our total list. And the recommended average max age for JavaScript files is between 6 months and a year. And each 100 sites far exceeded the measure of the average, which is being 6 months. And in summary, the JavaScript web crawler obtained data from 98% of the websites that we analyzed, and the overall security header usage was low. And we need to improve that in order to regain the trust of the users, and especially in this time where information is now more portable than ever. So that's my research poster. Thank you guys for watching. If you want more information and the data is in the description down below, along with the poster and the abstract and the source code of the project. And thank you guys for watching.